Okay, going through the topic of geometric design. Okay, and yesterday we started with one of the parts of geometric design, which is horizontal alignment. So in the horizontal alignment, we have the curves. Okay, the horizontal curves. Yesterday we talked about the horizontal curves. We looked at its different components, and we did one example as well in which we calculate the components. Another thing which is relevant to the horizontal curve is the super elevation. Okay, so we have used it in the previous topics as well, and yesterday we discussed the method of its rotation, that it is done in two stages. Okay, so if you want to have the super elevation, you have to go first from the normal slope, which is like this. Okay, you have to go from here to here. Okay, from normal to zero outside edge, and then from zero outside edge to full super elevation. Okay, so this part is called as tangent runoff, and this part is called as super elevation runoff. Okay, the first one tangent runoff, the second one super elevation runoff. So we need to calculate in how much distance the super elevation can be achieved. Okay, so this LR is the second part. Okay, which goes from zero outer edge to full super elevation. Okay, the second part. Okay. So how do we calculate it? You can see the equation over here. We need first of all W, which is the lane width. Okay, W is the lane width. N1 is the number of lanes rotated. Okay, number of lanes which you are rotating, meaning number of lanes you are rising. Okay, or number of lanes for which you are changing the slope. So N1 is considered on one side of the center line. Okay, one side of the center line. Okay, so if you have two lanes, okay, then N1 will be how much? If you have two lanes, N1 will be 4. 1. Okay, 2 lanes, right? Okay or not? Clear, everybody? Okay. But there is a small thing you have to consider is the median. I mentioned it yesterday as well. If you have a median, then both sides are separate. Okay? If you have a median, then both sides are separate. For example, there's 4 lanes now. Okay, on your demand, there are 4 lanes now. Okay, but there is a median in between them. Okay, so 2 lanes on one side, 2 lanes on the other side. Okay, so each side will be considered separate. Okay, so N1 will be how much again? 1. Okay, because still we are considering 2 lanes at a time. Because of what? Because of the median. Clear? If it was 4 lane without median, then center line is the center line. Center line is the center line of the road. So then N1 will be how much? You have 4 lanes without median. Then N1 is 2. Okay, because you will consider the 4 lanes total. Clear or not? Okay, with median you will consider each direction. Okay, and in each direction you will see where the center line. Okay, if you have without median, full road, yes. To what? Yeah, yeah. No, then it's the full lane. Because for one lane you cannot. Is it going somewhere or not? If it is one lane, can you have a lane like this? One lane, half lane going here, half lane going here. It cannot happen, right? So one lane is, you have to consider one. It cannot be less than 1. Got it or not? Okay, because for one lane, even the normal slope is not like this. Okay, so it's the full lane then. So it is one lane, it's a full lane always. Okay, so I was explaining N1. So lane width, N1, one side of the center line, and the center line will depend upon whether you have a median or don't have a median. Okay, then we have ED, the super elevation you are designing for. Okay, the value of super elevation which you are designing the curve for. Then we have BW. BW depends upon N1. The values are given here. Okay. In some other books, there is a whole table for BW as well. So you will see the value of BW from 1 to 6 to 7 to 8 links. Okay. Normally we don't have these many links. Okay. So BW for some of the lanes is given here, but there are other values as well. It depends upon N1. BW depends upon N1. Okay, it's called the adjustment factor for number of lanes. And then the last thing is this delta. So this delta comes from this table. Okay, what is this delta? The maximum change in gradient. Relative gradient means change in gradient. Okay, you are changing, right? It was normal. Now you are making a super elevation, right? So this is change. So maximum delta is the maximum change you can do. Okay, so that is delta. So these are the W, N1 and BW. They depend upon the road. ED and delta, they depend upon the design. ED is the design super elevation and delta depends upon your design speed. Let us look at this example. So we have a 4-lane highway, super elevation 0.04, meaning 4%, and 12 feet lane width. Rotating around the center line, highway is 60 miles per hour, and we have to find out the minimum length of super elevation runoff, LR. Super elevation runoff means LR. Okay, this is the equation. Okay, W is how much? Yes. What is W? 12 feet. N1? 2. Okay. There is no median mentioned. So the whole 4-lane is considered as one road and N1 is one side of it. Okay. So for 4 it will be 2 lanes. Okay. BW, ED is given. Okay, second line. So BW depends upon N1. Okay, so if N1 is 2, then BW is okay, and then we have the delta. Delta depends upon the design speed. Design speed is 60, so delta is 0.0045. Okay, how much is LR? How much? 160. Clear? Any problem in this? Clear? Okay. So this is, as I told you, the second part of the super elevation achievement. This one. Okay, you are going from 0 to 4 super elevation. This one is called the tangent runoff, represented with LT. And this is how we calculate LT. So you can notice here, then I need LR here. Right? I need LR, the super elevation runoff. That's why we calculated LR first. Okay? Sure. Okay. So if you look here, we go from the normal to 0 first. This is LT. So in the field, LT is first. But when you calculate, then you have to calculate LR first. Okay, because it is required in LT as well. Okay, ENC is the normal slope you have before the super elevation, before the curve. The normal slope, and ED was what? Super elevation. Okay. So if you apply this to the previous example, In the previous example, super elevation was given, LR you calculated 160, right? So I need the normal slope. Now they are saying if the normal slope is 1%, okay, so E and C will be 1%, 0.01 or 1%, and ED is 4%, which was given, and LR will be 160 feet. Okay, if you put these values, then LT will come out to be 40. Okay, so LR is 160 and LT is 40. Total 200. So you need 200 feet to go from normal slope to forced super elevation. The total distance required to go from normal to forced super elevation is 200. Okay. Now, which type of location we provide super elevation? Ramps, roundabouts. Roundabouts. Yes. Curves. You need your lips. Yes. Curves. Okay. Curves. Okay. You may not give super elevation at roundabouts. Okay. You may not. Okay. But on curves, on highways, it's required. So the super elevation is required on the curves. Okay, already explained. We have to cancel out the centripetal force, so we need super elevation on the curves. Okay. Now, should it happen before the curve or on the curve? This thing. When you are changing the cross slope. On the curve. Where do you want the super elevation? On the curve. On the curve, right? You want super elevation on the curve, right? Okay, so you should change the road to super elevation before, right? Before. Clear? Okay. But doing it, if you do the full change before the curve, it could become confusing for the driver because it will start to change very far from the curve. Okay. You are doing what? You are changing the cross section, right? Okay, the change of cross section is required at the curve. Okay, so the driver is expecting the change on the curve or near the curve. If you do the full change before the curve, that will happen very early. It may confuse the driver. Okay, that's why the cross section is being changed right now. Okay, so what we do to avoid the confusion for the driver, okay, and again to give him an indication that the curve is coming, we do 60 to 80% of this before the curve. Okay, and the remaining 20 to 40% on the curve. Got it? Okay, a major part has happened before the curve, and some last remaining part is happening on the curve. Clear? Okay, this is better for the understanding of the driver that a curve is coming and he gets prepared and so on. Okay, so anything between 60 to 80% is fine. The normal practice is 67%, which is around 2/3. Okay, so 2/3 before the curve and 1/3 on the curve. Okay, but this is for the sake of the driver, for the comfort and understanding of the driver. Okay, the ideal situation is we should do it before the curve. The whole thing should be done before the curve. Clear? Okay, spiral transition curve, again something which we talked about yesterday as well. So in normal situation, you have a tangent and the tangent is attached to a curve. Okay, so both of them are meeting at a point. The tangent and the curve are meeting at a point. If I am slightly behind the point, I am on the tangent. When I go on this point, then I come on the curve, right? Okay, so the transition is happening at one point. Transition of the tangent to the curve is happening at a single point. If you are on this point, you are on the curve. If you are before this point, you are on the tangent. Okay, so it's a sudden transition. Okay, it's an instantaneous transition. Okay, which is fine. Okay, because the curve is designed for the speed as well, the speed of the road. Okay, which is fine. Now, most of the cases, fine. Okay, but in some cases, the curve could be very sharp. The circular curve which you are designing, which you have designed, it could be very steep, very sharp. Okay, so in those cases, we try to provide some extra safety for the driver by inserting a spiral transition curve between the tangent and the circular curve. So circular curve is not directly joined with the tangent. The tangent is joined with the spiral curve, and the spiral curve takes the driver to the circular curve. Okay. Now what is the difference between a circular curve and a spiral curve? Anyone? What is the difference between a circular curve and a spiral curve? The radius varies. Okay. In circular curve, radius is constant. In spiral curve, radius is varying. Okay. So this is why it becomes better for the driver, because the radius is changing gradually. On the circular curve, it changes to radius, whatever is the radius. That's it. Okay. But on a spiral curve, it changes gradually. Okay. So it starts from the tangent. Okay. Now for the tangent, there is no curvature, right? Tangent means no curvature, right? Okay. So degree of the curvature on the tangent is 0. So it starts with 0. Okay. Starts with 0, which is ideal. And then it gradually changes. So from point 1 to point 2 to point 3, it is changing slightly. Every point is changing slightly. And in the end, when you reach the curve, the circular curve, the degree of the spiral curve equals to the degree of the circular curve. Okay? So, and this is why, because of 0 degree, yesterday I mentioned that the radius is infinity. Because the degree of the curvature is what? 0. Okay? So, now we already mentioned that the advantage of a spiral transition curve is better safety for the driver. Okay, it is safer for the driver because he is changing the direction point by point, not suddenly. Okay, clear? But there is a downside as well. Which one is more difficult to draw, a circular curve or a spiral curve? A spiral curve, right? A circular curve. It's a circle, part of a circle, right? You know the radius, you can draw the circle, no problem. Okay, but a spiral curve is higher degree. So every point something is changing. It's difficult to draw. Okay, and we are not talking about drawing on a piece of paper. We are talking about constructing it in the field, on the side. Okay, so although spiral transition curves are safer, but they are also more difficult in construction. Okay. Something which is more difficult has more cost as well. Okay, keep it in your mind. Okay. So that's why they are not used everywhere. They are used in special cases, and they have given us a limit that if your horizontal curve is very sharp, how much is very sharp? More than 3 degrees. It's considered very good. If you have this situation, you should go for a spiral transition curve. And one thing which is not mentioned here, but was mentioned yesterday, that it should be a high-speed road. A sharp curve on a high-speed road. Okay, so we were talking about roundabouts or intersections or local streets. Okay, so if we have a sharp curve on these type of roads or streets or these type of locations, no problem. Because the car is going on a speed of 20-30 kilometers per hour, no problem. It can still manage without spiral curve. On a high-speed road, it is absolutely necessary. Okay, so the first benefit I already mentioned, that it becomes safer for the driver to change the direction. The second benefit is the super elevation. Okay, we said we need to achieve super elevation. Okay, most part of it before the curve, and some part of it on the curve, right? On the circular curve. Okay, but now we have what? We have the tangent, so we will do most part of it on the tangent, and the remaining will be where? On the spiral curve. Okay, so when the driver reaches the circular curve, now you have the ideal situation. That full super elevation is already there. Okay, so it provides you the extra space required to achieve the full super elevation while the driver is turning. So he's turning, right? He's on the curve, but not the main curve, but the spiral curve. So it provides you the space to achieve the super elevation. It provides you a space for doing the widening of the lanes as well. Okay, on high-speed roads again, we have to increase the lane widths. Why? For who? Which?
Emergency.
Emergency.
Vehicles.
Yes, heavy vehicles. Okay, for heavy vehicles. Because they cannot make the turn in a circular path. You need to provide them more space. So again, like we did with the super elevation, if you want to increase the width should also increase gradually, right? So where will you make this gradual change? On the spiral transition. Clear? Okay. And the last thing is the appearance. It makes the appearance of the curve to the driver more comfortable. Okay, for the driver. Just for the driver. Okay. Sometimes you look at the curve and it seems dangerous to you. Okay, or it's designed for a speed of 100 kilometers per hour. Okay, but the way it looks dangerous. Okay, just in the morning I was reading that if you have a horizontal curve and a vertical curve at the same location, so the horizontal curve can change the appearance of the vertical curve for the driver. So if you have two vertical curves, one with the horizontal, one without the horizontal, both of them are for the same speed, with the same length, everything is same. But because of the horizontal curve, this one may look bigger or smaller to the driver. Okay, so this is what they are talking about. They are same distance. Okay, but because of the because of the side distance, because of how it's looking to you, it can change the appearance. Okay, so when you have a spiral transition curve, the appearance of the curve for the driver improves. So he thinks the curve is safer. So he doesn't try to change the lane or doesn't try to brake suddenly and so on. Because if he is doing any of these things, it's dangerous, right? He thinks the curve is dangerous, okay, or it's very sharp, let me change my lane or let me slow down. Okay, so sometimes drivers brake very hard or they suddenly change the lane, which is dangerous. So it improves the appearance and then it encourages the driver to just keep on going, okay, in the same lane, in the same way. Okay. For the spiral curve, first of all, let us look at the geometry of the spiral curve. Okay. So we said we have a tangent, okay, and the tangent is connected to the spiral curve, right? So this is the point where the tangent is connected to the spiral curve. Okay, TS, tangent to spiral. Tangent to spiral. So this is the start of the spiral curve. Okay. So then you will move on towards a circular curve. Okay. So a spiral curve will end and circular curve will start. Okay. So this point is called an SC, spiral to circular. Okay, or spiral to curve. Got it? Okay. Then you will have the circular curve, and the circular curve will also end. When the circular curve ends, like we did at the start, we will not connect the circular curve with the tangent. We will connect the circular curve with the second spiral. Okay. So now this point is called as circular to spiral or curve to spiral. Okay, CS. So this is the beginning of the second spiral. Okay, you have spiral at the start, spiral at the end. Then when this spiral ends, you are at the tangent now. Okay, so the end of second spiral is ST, spiral to tangent. Okay, start of first one, tangent to, you go from tangent to spiral, then spiral to curve, curve to spiral, spiral to tangent. Okay, what was PI? Point of intersection. Delta is the total angle which you are trying to cover. Okay, now this angle is achieved through three curves, right? Now we have three curves. Okay, two spirals and one circle. Okay, so some of the delta is part of the spiral and some of the delta is part of the circle. Okay, the part which is covered by one spiral is represented with small delta. Okay, I'm calling it small delta. We are calling it something else, no problem. Okay, just remember the shape. Okay, this is small delta, this is capital delta. Okay, so we said what? The whole delta is covered by two spirals and one circle, right? Okay, so two spirals plus one circle gives you the whole delta. If you want the angle of the circular only, take the whole delta minus the two spirals. Clear? Okay. What else? Yeah. From the point of spiral to the intersection, we have the tangent length of the spiral. Okay, the tangent length of the spiral Ts, which is given by this equation. And the most important component of the spiral curve is the length. For the length, we have these equations, which give us the minimum and the maximum of the length. Okay, in this equation we are using S. S means the speed of the curve, the speed of the road, and R means the radius. Radius of what? Spiral or circular? Circular. A spiral doesn't have a constant radius, right? You cannot put an R here for spiral. Okay, so this equation is for maximum, these two are for minimum. They will give you two different answers. Okay, so let's say one of them gives you 100, the other one gives you 120. Both of them are under minimum, right? So which one will be your final minimum? 100 or 120? 120? Why the highest? Okay. Why 120? Why not 100? Safer. So you are talking about the curve itself now, right? If I take more length, the curve will become safer, which is true. Okay. But in general, you have curve or dimension of the column or quantity of material, whatever. Okay. And somebody gives you two values and he says pick one of them as a minimum. They always pick the higher one as a minimum. Because when you pick the higher one, the other one is satisfied. Okay. So if you have 100 and 120, if you pick 100, the other one says what? 120, which is not satisfied, right? But if I pick 120, then both of them are covered. Okay, that's why we take the higher one. Okay, so from here the higher one and the other one will give you the maximum. Now, between them there could be thousands of feet, right? So the first minimum could be 1,000 feet and the maximum could be 10,000 feet. Okay, so which value from this range I will pick? It's a range, right? I cannot do the whole range. I still need one value. Okay, so there are some recommendations to have an exact value. The first recommendation is pick a value from the table. From where did this table come? From the book. From where did the book come? From the authors. From where did the authors come? From their parents. Okay, and this is it. Clear? Okay. This is as deep as I can go. Clear? Okay. Don't ask me any other questions. So we have one recommendation: pick the value from the table. Okay, an exact value. The second recommendation is, we said on the spiral curve we can do the transition of the superelevation, right? Okay. So the second recommendation is the length required for superelevation, make it the length of the spiral curve. Okay. So we have an equation for LT, we have an equation for LR. Calculate them, add both of them. This becomes your length of the spiral curve. Okay. Second recommendation. The third recommendation is just make the length equal to LR only. Okay, so you have three choices to pick an exact value. The first choice is from the table. The second choice is LR plus LT. The third choice is LR only. Okay, in all three cases you have an exact value, not a range. Okay, but you have to keep in mind that whatever option you are choosing, it should not be out of the range. Okay, so for example, you have a value here 220 feet. In this table you have a value 220 feet. But when you calculate the range, your range is from 100 to 150. So 220 is out of the range. So 220 is not an option then. Got it? Okay, when any of the option is out of the range, you will not consider it. Clear? Okay, let us look at this example. We have 4 degree curve, two 12 feet lanes, design speed is given. maximum super elevation is given. For the speed, coefficient of side friction is given. Normal slope is given. What are they asking for? They're asking for length of the curve. First of all, find out the length of the curve. Secondly, length of the spiral curve. And then find out the stationings of its start and end points. Okay, the 4 points are the start and ends of the spiral curve. Okay, so we start with the length. Okay, to find out the length, I need what? I need two things, right? Speed and radius. Okay, speed is given 60. Radius, for radius, I have what? Which parameter will give me the radius? Which angle and the length? Which angle you are talking about? 38 or 4? 4 degree. Okay, the degree of the curve. Okay, yesterday we looked at the relationship between the degree of the curve and the radius. Okay. So radius equals to this. Okay, so 4 is the degree of the curve. Okay, how much is the radius? Say again. Okay. So now we can calculate the minimum and maximum length. One side note here, the degree of the curve was how much? 4. And this is the reason we are going for the spiral curve. Okay, it was more than, if you have more than 3 degrees, then you should go for the spiral curve. Okay, so I need now minimum and maximum length of the spiral curve. Speed is 60. No conversion required, is already there in the equation. Okay, and the second one? 1? Okay, so we said we will pick which one? 150. Okay, so this is my minimum now. Okay, and the maximum? Point? Okay, so I can pick a value between 150.6 and 336.8. Okay, any value between them is fine. Okay, it will not be dangerous. Okay, so I will go for the recommendations they have given. The first recommendation was, look at the table. My speed is 60 miles per hour. For a speed of 60 miles per hour, the length is 176. Okay, is it acceptable according to the range? Yes. Okay, it's between the two values we have. Okay, the other recommendation was that it can be only equal to LR, or it can be equal to LR plus LT. Okay, so one recommendation is 176. Okay, for LR and LT we have equations, right? Okay, so whatever you need, you have to calculate LR first. Okay, so LR needs the lane width, which is 12 feet. Okay, it needs N1, which is the number of lanes you have. We have 2 lanes, so N1 will be how much? 1. Okay, and we need what? Design super elevation. How much? What is the design super elevation? 0.06. Did they say it is design super elevation? Maximum super elevation. So there is a difference between them. Okay. Maximum means you cannot go above this value, but your design value can be anything between this value or less. Okay. If they asked me to design a curve, we did one example yesterday. If they asked me to design a curve, I'll take this maximum value and design my curve. Which curve? Circular curve. Circular curve. Am I designing a circular curve? No. Circular curve is already there. I found the radius for the curve and the degree of curvature is already given. Okay. So now I need to find out what was the exact super elevation taken for the design, which could be 6%, but it could be something less as well. Okay. So radius is s square 15 e plus f. Okay, s is 60 miles per hour, e is what we are trying to find out. Radius we already found. Okay, it was 1432.4. Okay, and f is a coefficient of side friction. It is given in the question. How did they get it in the question? Because there is a table for it. Okay, and from where did we get the table? I have already explained it, right? Very good. So what is there? So f is 0.12 for the speed of 60 miles per hour. F is 0.12. How much is the super elevation now? Tell me. Okay, 4.7%. It's not the maximum value. Okay, so if you took the maximum value, it would have been wrong because it will not be according to the radius you have. Okay, clear? Because the radius is already there, I am calculating super elevation. If it was not there, I was going to design it, then I will design using any value. Okay, I can fix my own value. Okay, coming back to LR now. So ED is 0.47. Okay, BW depends upon number of lanes you have. Okay, you have 2 lanes. So we said N1 is how much? 1. Okay, so N1 is 1 means BW is also 1. Okay, and delta, this delta depends upon speed. So my speed is 60 miles per hour, delta is 0.0045. Okay, so how much is LR? Say again, 125. Now I'm in this range, right? My LR is 125.3 feet. Can I take LR as my length of a spiral? No. My length of a spiral should start from 150 onwards, right? So this one cannot be taken. Okay, we calculate, but this one cannot be taken. So now we can calculate LT then. Okay, so LT is this value. My super elevation was 4.7%. Normal cross slope is given in the question 1%, 0.01 or 1%. LR you just found. So how much is LT? Yes, 0.01 or 0.047 into 125.3. How much? 26 point. Okay. So their total is how much now? How much is total? 1? Sorry, 1, it was 126, right? 126.6. Okay, the total is how much? 0.9. Okay, so this could be also one of the lengths, right? because it is in the range. So I can pick 176 or I can pick 151.9 or I can pick any other value if it is in the range. Clear? Okay. Let us pick this one. Okay. So my length of a spiral is 176 feet. Okay. So now I will calculate the stationings. For the stationings, they have given me one of the points. Which point? The point of intersection. Okay, the station of point of intersection is given, which is 1162. Okay, from 1162, this point, I can go back to the start of the first the first spiral, okay, and I have between them tangent length, okay. Tangent length can be calculated from this equation, okay. So my LSP is the length of the spiral I have chosen, which is 176. Then I have a small delta somewhere here. Small delta is will come from this equation, okay. D is the degree of the curve, 4. This is 176. So how much is small delta here? And the full delta was given as 38 degrees. So how much is this? Yes. Okay, it's degrees. So how much is the length of the tangent? What's funny? I'm asking you. Hmm? Okay, so we know PI from here to here it is 581.58. So how much is TS? What is stationing of TS? How much? 580.42. Okay, from TS to the next point, I have the spiral curve. Okay, so you will add the length of the spiral curve, 176 in this. How much will be that? 7 5 7 plus 5 point 42. Okay, between these 2 points I have what? Which curve is this? The circular curve. Okay, so I need to find out the length of this curve. Okay, the length of this curve is this. Okay, I already know the degree of the curve, which is 4. Okay, this was the delta for the curve, angle of the circular curve. Okay, without the spiral. Here we were not talking about the spiral. Now we have added the spiral, so this delta is not the full delta we have. Okay, this is a remaining angle. Okay, so the full delta was, so 38 minus the spirals at both ends.
Both spirals are equal.
Yes, equal. So how much is this? Huh? No, this angle. 1696. Okay, now you were telling me that length. Okay, how much is that? 774. Okay, so now I will add this into the last point. Okay, so it will give me the circular to spiral. How much is that?
15 plus 30.
Say again.
15 plus 30.
Okay. Okay, so now I have reached this point. From this point to this point, I have the second spiral. Okay, so I will add the length of the spiral again, 176. How much is that?
17 plus 06.
Plus?
06.
Okay, so a circular curve was given. They were asking us to design the spiral curve and found out its station. So first of all, we found the length of the spiral curve. Okay, since the circular curve was designed, we had to find out for what super elevation it was designed. That's why we found super elevation. Then we fixed the length of the spiral curve, and then we moved on to the calculation of the stationings. Clear? Okay. Any questions?